in 9.2. So we're going to graph today and we're going to graph tomorrow. Today is the basics, basically. So they're going to be the simple rational graphs. We're going to look at two different kinds. Okay, so there's going to be a lot of notes because this type of graph, it's a little tedious. Okay, so yes, there's going to be a lot of notes today, but it's going to be really, really important that you make sure you get everything down. So 9.2, if you want to follow along, that's where we're at. Okay, so to start, rational functions. We have this general form where we have the function f of x, and then you're going to have a function p of x divided by another function q of x, okay? So we're going to have those, the p of x, the q of x, we have some expression. Okay, so it's not just going to be as easy as graphing a line or a parabola or something like that. You now have a little bit more work, and these graphs look a lot different than what we are used to seeing. So remember, a few chapters ago, when we graphed and we had asymptotes. What is an asymptote? Yeah, it's like the restriction. Okay, so how did we label an asymptote? X equals and y equals, and then what does it look like? A dotted line, yep. All right, so you're going to have both the vertical asymptote and the horizontal asymptote in one graph from now on. And then remember, we get really, really close to those asymptotes, but we never touch it, and we definitely never cross it. So essentially, you're going to have the vertical asymptote and the horizontal asymptote crossing each other, and then in two of those quadrants that those two form, you're going to have basically what's called a hyperbola. Okay, you're going to have a curve basically, and you're going to have two of them. This is where it comes from. Okay, this rational function here. The denominator, you're never going to have 0 there. Okay, because if we do, we're just going to have a line, right? And we're not going to deal with that. So you will always have something on the top, something on the bottom, and that's what you're graphing. Okay, we all got this down? Okay. Here's what it looks like. So right now, the red is your asymptote. So the vertical line, that's your y-axis, right? Well, what is that as an asymptote? X equals or y equals? X equals, and what does it equal? 0. And then the horizontal one? Y equals 0. Okay? So right now, that's what your two asymptotes are. Okay? And then you see the blue line. Those are your branches, and that's what we call them. Those are the branches. Those are the part of your graph that's going to get really, really close to those asymptotes, but never, ever cross. So you notice we only have the hyperbola in the first and the third. There's a reason why it's in the first and the third. Okay? These are symmetrical. So what does that mean if they're symmetrical? They're the same, right? Yes, I can reflect one onto the other and it's the exact same. That will always be true. So when you go to graph these, if you just pick points in one of the quadrants, okay, whether it's to the right of the asymptote or above it, to the left or below it, you know, it doesn't really matter. As long as you pick a point there, and if you can get a point to work out there, that's where your graph is going to be. Does that make sense? Okay, and then you know if it's going in there, then it's going to be in the opposite quadrant. Does that make sense? Because it's symmetrical, it's going to reflect on top of the other one. Okay, so again, the hyperbola. One vertical asymptote, one horizontal asymptote, two branches that are symmetrical. And you have two different forms that we're going to graph. Okay, so everybody have this down, these bullets. Very important to have down. Okay? All right. Here is one of the forms. Y is equal to A divided by X minus H plus k. Now, something should look very familiar. The h and the k. The h and the k. So remember, the h and the k in our graphs, what did they do to our parent graph? Yeah, it moved it left and right or up and down. What does the h do? Does that move it left and right or does it move it up and down? Left and right. But if I see a negative h, am I going in the positive direction or the negative direction? Positive. So then if I see x plus h, what does that mean? You're going to the left. Very good. All right, so then the k moves my graph up and down, okay? Now, you're really not going to have to mess with those transformations. You just have to remember that the k value is for your vertical shift, but that's your horizontal asymptote. K is your horizontal asymptote. That's all you have to know. And then your h value, take the opposite of it, and that's your vertical asymptote. Okay, so this looks kind of complicated to graph, right? That y equals a over x minus h plus k. That kind of looks a little complicated. Okay, but it's going to be extremely easy. A is just going to be a number.
Oh, it's given.
Mm-hmm. Yep, it's given. A is given to you. Okay, so two asymptotes, and then you're just going to pick points. You're going to make a big t-table, basically. You probably want to get a minimum of 4 points in your t-table for these graphs, a minimum of 4. That way you know exactly what the curve is going to look like. Does that make sense? Minimum of 4, so you see what the graph looks like, okay? So, everybody have these bullets down? Because this is the first form, we have a second form. Good to go? All right, here's the second form. Y is equal to ax plus b over cx plus d. Looks totally different, right? You don't have an h, you don't have a k. So you have to remember the asymptotes for this one as well. But again, they're still super easy. Your vertical asymptote. Okay, if it's a vertical line, is that x or is that y? Vertical asymptote, it's an x equals, right? Okay, so your vertical asymptote, to get what that is, all you're going to do is take the denominator, cx plus d, set it equal to 0, and solve for x. So then x is going to be negative d divided by c in this general case, but you're going to have numbers there. So really, if I have a denominator of x plus 4, where's my asymptote at? So an example, if my denominator, so y is equal to some number on top, don't care what that is, but then I have x plus 4 on the bottom. Yeah, I'm going to draw a vertical asymptote at x is equal to negative 4, and that's it. That's all I have to remember. Pretty easy, right? Just got to remember that. Okay, and then the horizontal asymptote is honestly even easier because you really don't even have to solve for anything. All you're going to do for the horizontal asymptote, which is a y equals, right, which we would have right here, y equals some number. Well, we get that number from taking the coefficients in front of the x's. So a over c. And then just simplify what you need to.
Are those going to be given?
Yeah, those are always given. Yep. And that's all you're going to do. Y is equal to a over c and simplify. And then you're going to draw your two branches. You could have fractions, you could have whole numbers, you could have negatives. Yep. All numbers are possible. Yep. Okay? Questions on that? Got all of this down. It's easy. It's just kind of a lot to remember.
Okay, how do you know which form to use?
Yeah, the forms you're just going to get used to seeing and which way to memorize it. Yeah, that'll come with time.
I was gonna ask, like, how do you know the difference, like, when
Yep. All right, we ready? Ready to graph one? Okay, here we go. So we're going to graph y is equal to 3 divided by x minus 1 plus 2. Okay, what I want you to do to start this, I want you to make these as neat as possible, because that's just going to make it a lot easier for you to remember for the quiz on Tuesday and then the test next Friday. It's just going to make it easy for you. So to start off to the side, I want you to write out the vertical asymptote, the horizontal asymptote, and then we got to talk about domain and range. Okay? Real easy though. Real easy. So let's start with the vertical asymptote. If it's a vertical asymptote, remember it's a dotted line that's vertical. Is that an x equals or a y equals? That's an x equals. Okay, remember, in this form, I basically have y is equal to a over x minus h plus k, right? Okay, which one is going to go with the x, the h or the k? The h. Okay, so here is x is equal to h. So what is that in our case? Positive 1, because remember I always take the opposite. All right, and then the horizontal asymptote, which is the dotted line horizontally, that's going to be a y equals, and what does y equal? The h or the k? Yeah, it's the k, because that's the only one left. So then here, it's y is equal to positive 2. Okay, let's talk real quick about domain and range. Domain and range. Okay, remember, we really start with all reals, right? And then we put restrictions on because of our asymptotes, right? Okay, so if I have the domain, that's my x value, right? Right? Range is my y. Okay? What is my only restriction for my domain? Hold on though. I only have the asymptote at 1. I'm not saying it's bigger than 1, I'm not saying it's less than 1. So what I'm saying is I only have one restriction and one restriction only. All reals except x cannot be 1. That's it. So I literally just write that. All reals and x cannot be equal to 1. Super easy, right? No thinking even involved. So then what's the range? All reals and then y cannot be equal to 2. Yep. So honestly, this domain and range is even easier because you just have the numbers given to you. You just have to make sure you remember where to get the numbers from. Okay. Questions on that?
How do we know if it was in like the first and third quadrant?
How do we know what quadrant it's going to be in?
Yeah.
That's what we're going to do next. We are going to graph the asymptotes first. Okay, so let's go ahead and do that. So we are just going to plot these. And since my x and y values are just 1 and 2, I'd probably go out, I don't know, maybe to 5 or 6. Okay, just give you enough room to put some points on. And remember, I don't need every single one labeled, but just make sure I know what your scale is. So I just put 6 and -6, and that's all I whoa, stumbling there. All I will require. Okay. So I'm going to put on the asymptotes first. Okay. So I have x is equal to 1. So I go to where x is equal to 1. And I draw my dotted line. X is equal to 1. Okay, then I go to where my y is 2. And I draw in y is equal to 2. All right, that is where my 2 asymptotes are. So I'm gonna put red dots. I'm either gonna be in the first and the third, or in the second and the fourth. Okay, that's where I'm going to be. So from here, I just have to pick points. Okay, now, someone asked about what the A was, that 3. Remember, the A in all of our equations before flipped our graph if it was what? If it was negative. Is it negative?
No.
No, so I should look like normal. So remember, a positive graph looks like that, right? So if I know that, that's where I'm going to kind of start with this. So I should, if that's the case, if I didn't flip, I should be where? First and third. So I'm just going to pick points there. Okay? So in red, I'm going to put my t-table together. I'm actually going to move this over. All right, so x, y. I'm going to plug in values for x. Okay, I'm going to plug in values for x. So if I need to be in this first quadrant here, what x value should I pick? 3, 4, 2. Do I pick 1?
No.
Why not 1? Because it's the asymptote and I can never touch it. Very good. So let's pick 2 and then let's pick 3. Those are easy numbers. All right, so then I'm going to plug those in. 3 divided by 2 minus 1 plus 2. Well, 3 divided by 2 minus 1 is
3.
3. 3 plus 2.
5.
5, that's an easy number. So 2, and then go up to 5, graph that point. And then go ahead and do the same thing with 3. 3 divided by 3 minus 1 plus 2. 3 divided by 3 minus 1. 3 halves. 3 halves plus 2. You can get a calculator out. 3 halves plus 2, you said what? 3, yep, 3.5. Now, if you didn't want to deal with 3.5, what number could I pick instead of 3?
4.
4, because then you got 3 divided by
2.
3 plus 2. Yeah, that would be a little bit easier. But it doesn't matter, because you know how to graph 3.5. And that's all I will need, because do you see the curve?
Yes.
I'm going to get really close to this vertical asymptote and really close to this horizontal asymptote, and there is my first branch. I'm halfway done. And so far, I haven't hurt my head yet, right? Not too bad to think about. All right, so now I have to be in what quadrant? Because it's symmetrical, I want to fold it on itself. So where's it going to go? Third quadrant. So what point do you want to pick in the third?
-2.
Hold on. What do you want to pick first?
0.
0. Absolutely pick 0. Because that's not touching an asymptote, and that's where I want to be. Because I want to be down here. So I'll pick 0. So that means I get 3 divided by 0 minus 1 plus 2. Well, that's going to be 3 divided by -1, which is -3. -3 plus 2. -1. So 0, -1. And then give me one more point.
-2.
-2?
Yeah.
Very good. Because then I get 3 divided by -2 minus 1 plus 2. So 3 divided by -3, -1, -1 plus 2. 1. 1, 2, 1. Do you see this curve now?
Yeah.
It's going to get really close to that horizontal and then really close
Wait.
to the vertical.
Shouldn't it be on you -1? You did.
What'd I do?
-1.
Oh, sorry. Yes. Sorry. Thank you. Just seeing if you're on your toes. Yeah, we're so close. Right there. And now you are done with your graph. And you see how, if this was a perfect graph, you're going to flip those on each other and they're going to be symmetrical. Okay?
Is there like any way that we can check if the points are symmetrical or not?
No. No, as long as you have your t-table and you're going through the math, you'll be fine with those points. And there's no right or wrong points to pick. There's never going to be right or wrong points to pick. So I might have picked the 2 and the 3, but somebody else is going to pick 4 and 5. It's okay. It's in the right place. Okay? Great, let's try one of the other forms. So y is equal to x minus 2 divided by 3x plus 3. Okay, so now we have those two polynomials, top and bottom. So now we go to the second form. So remember, we're going to start out nice and neat. We're going to start out with our vertical asymptote and our horizontal asymptote, and then state the domain and range. Okay? So on this one, vertical asymptote, where does that come from?
You set the bottom, you set the denominator equals 0.
Yes, you set the denominator equal to 0. So 3x plus 3 is equal to 0. So then I'm going to just subtract 3. So 3x is equal to negative 3. And then divide out that 3. So x is equal to negative 1. And then the horizontal, where does that guy come from? A over C. Okay, what is your A
1,
and what is your C?
3.
So then y is equal to 1/3, right? And then you're going to leave that.
Domain and range are the same thing.
Yep, and then the domain and the range, we always start with all reals. But then what's our restriction on our x's? Oops, yep, x cannot equal negative 1. And what's the restriction on the y? Yep, y cannot equal 1/3. Very good. Okay, any questions on that? Okay, so next up, we're going to just go ahead and start to graph. So that one. Okay, so my vertical asymptote, I'm going to go to x equals negative 1 and draw in my vertical dotted line. X is equal to negative 1. And then with the y, that's not going to be super accurate, right? So as long as you're between what and what, you'll be good. Yeah, 0 and 1. So then there's the y equals 1/3. Okay. Now, what points do we want to pick?
Well, how do we know it's going to be in the first and third?
How do we know if it's going to be in the first and the third or the second and the fourth?
It's the A's, if they're positive on
C
the
and a D would be 2.
But, yeah, what happens with the C and the D? Okay, I'll tell you right now. This is in the second and the fourth. How do we know that it's going to be in the second and the fourth?
negative
Because
2.
it's a negative 2.
Mm-hmm. You have that negative. Okay?
Any negatives in the second?
Pretty much flipped.
There's 2 negatives.
You still have a negative. Yep, you're good. Still have that negative. Okay. So, what point do you want to pick first? You want to pick 2? All right, so then I have 2 minus 2, and then 3 times 2 plus 3. Right away, what do I get it right? 0. Because 2 minus 2 is 0, and then I don't care what that denominator is, because it is going to be 0. Now, do you ever want to pick an x value that's going to make that denominator 0?
No.
No. Make sure you don't have something that's undefined. Okay? All right, so then go ahead and graph that. And are we okay there? Are we touching our asymptote? Nope. So we're really close. And then what else do you want to pick?
0.
0?
Yeah.
Sure. So then I get 0 minus 2 divided by 3 times 0 plus 3. So negative 2 2/3, right? Okay. -2/3. And again, I just have to be accurate, so where do I have to be between? 0 and 1, yep. And then you can sort of see your curve. If you can't, pick a third point and then just plot that as well. Okay, so there's your one branch.
So a minimum of 4 points is just like 2 for each.
Yes, 2 for each. Yep, minimum of 4 is 2 for each side, for each quadrant. Okay, so now that I knew I was in the fourth, I need to be in the second because I'm symmetrical. So what point do you want to pick to get into the second? I heard -2?
Yeah.
All right. So then -2 minus 2 over 3 times -2 plus 3. So then I get -4 over, what's -6 plus 3? -3, right? But negative divided by a negative is a positive 4/3. And does that fit where we're at? So where should I be between the 1 and the 2? Somewhere in there. And what's your last point you want to pick? -4? So -4 minus 2 times 3, or 3 times -4 plus 3. So I have -6 over, what's -12 plus 3? -9. So this becomes 2/3. And where does that have to be between? What? 1 and 0? Am I going to be touching the asymptote?
No.
No, I'm still okay. So I go 1, 2, 3, 4, and then right about here. And then I just draw my second branch. And you have the second form. Right? Hopefully that makes a little bit of sense. These are just the basics. We're going to do more tomorrow, and then we're going to review all of this on Friday, all of this on Monday, and then Tuesday you're going to take your quiz. Okay? So write down the assignment, and then go ahead and get started on this